Hello everyone. Today we're going to talk about X and Y intercepts. So we've been talking about linear relations, so things that make a line. So the X-intercept is the spot where the line crosses the X-axis. So X-intercept is where it intersects the X-axis. And then the Y-intercept is where it intercepts the y-axis, intersects the y-axis, okay? Axis. Lord have mercy, that's a lot of words to say. Okay, so we're talking about these 2 points, and this axis is labeled X, so that means that this is the X-intercept. This axis is labeled Y, so this is the Y-intercept. In math, the X-intercept can also be called a root, a zero, or a solution to an equation, okay? So that's just, these are other things. Anytime you see root, zero, or solution in when we're talking about functions, that means X-intercept. Those words are all pretty interchangeable. So it was pretty easy on that graph to see the points where it crosses the axes. Okay, so visually, it's easy to find the X and Y intercept. You just look where it crosses. But what if you only have the equation? You don't actually have the graph in front of you. So this says to find the X-intercept of an equation, set Y equal to 0 and solve for X. So that's what we're going to do. So for the X-intercept, we're going to replace Y with a 0. So we're going to have 0 equals negative 2X plus 5. And then we're going to solve for X. So first, X is being multiplied by negative 2. Then once we get that, we're going to add 5 to it. So what we want to do to solve for X is undo those steps. So we have to work backwards. So we're going to subtract 5 first because we're adding 5 to the value. So we need to subtract 5 to get rid of it. 0 minus 5 is negative 5. And then our negative 2x comes down. And 5 minus 5 is 0. So we'd have plus 0, but that doesn't actually mean anything, so we can leave that part out and just say that these two cancel each other. Now, X is being multiplied by negative 2. In order to undo multiplication, we divide by negative 2. So we're going to divide both sides by negative 2. This is going to give us X equals positive 5/2. But the X-intercept is a point on a graph, and points have to be written in ordered pairs. So we have to have an X and a Y value for our X-intercept. So this says that X equals 5/2. So that's easy. But what does Y equal? Well, if you remember in the beginning of this, we replaced Y with 0. So the point for our X-intercept is 5/2, 0. You could also write this as 2.5, 0. Those are both acceptable. And this version might actually help you graph it easier. Okay, then we have the Y-intercept. So in order to find the Y-intercept, we set X equal to 0 and solve for Y. So remember, whenever you solve for the X-intercept, you want to end up with X equals something. So you have to leave the X in the equation. When you solve for the Y-intercept, you want to have Y equals something in the end. That means we have to leave the Y in the equation. So instead of replacing the Y with a 0, we're going to replace the X with a 0. And negative 2 times 0 is 0. So we get Y equals 0 plus 5. And 0 plus 5 is just 5. And I don't know if you remember, but whenever we did slope-intercept form of a line, that slope-intercept form is y equals mx plus b. And that's the form this equation is in, and b is equal to our y-intercept. That's what b represents. So we really technically could have just looked at this equation and said, oh, the y-intercept is at 5. And to write that as an ordered pair, it's x then y. The x value is 0 because that's what we plugged in for x, and the y value is 5. Okay, and we can use those 2 points to graph our line, because all it takes to graph a line is 2 points, because once you have 2 points, you cannot make any other lines. There's only one choice for how that line will go. So it only takes 2 points to make a line. So now let's actually do an example where we're going to graph this, okay? You saw in the last one, in the last worksheets, that we could graph this in from y equals mx plus b using using the slope and the y-intercept. But this is a different method, and you have to do it this new way, because that's the whole point of this activity, is to learn a different way to do it and to see the value of the x and the y-intercepts. So let's go ahead and calculate our x-intercept. When we do an x-intercept, we set y equal to 0. So we're going to have 0 equals 5x minus 1. And we want to solve for x. So we're going to add 1 to both sides, and we get 1 equals 5x, and those equal 0. Divide both sides by 5, and we get 1/5 on the left, and 5 divided by 5 is 1, and 1x can just be written as x. So we get x equals 1/5, which represents the point 1/5, 0. That's our x-intercept. And now there are 2 ways for us to find our y-intercept. The first way is to set x equal to 0. So we're going to have y equals 5 times 0 minus 1. So 5 times 0 is 0, minus 1, y equals negative 1, which is the point 0, negative 1. However, if we look at our original problem, that problem is in the form y equals mx plus b, and b is our y-intercept. So this already tells us that y equals negative 1 for our y-intercept. Okay, so we could have figured that out without doing any math because of the form this was in already. But now we're going to graph these 2 points. So to go over 1/5 and up 0, that's what that means. So x is this is the x-axis, so it tells us to go to 1/5 on the x-axis, which is somewhere in here. It does not have to be perfect at all. And then it tells us that the y value is 0. So that means we're going to stay at 0 on the y-axis, which is right. Oops, that's not what I meant to do. Which is right in here, and so we're already at our point. So then on the y-axis, it intersects at negative 1. And now we have 2 points, and we can make a line. Now this line is very steep, and it's very hard to draw, but it's close enough, okay? So that is a completed answer to number 1. And I'm going to do all the odd ones for you, but make sure that you complete every single problem. You have to have all 7 problems written down so you can get the odd answers from the video, or you can do them on your own, but either way, you need to check your answers and make sure you've done them correctly. The answers for the evens are posted. Yeah, so let's go on. I'll do example number 3. Okay, so our x-intercept we find by setting y equal to 0. So we have 0 equals negative 3x plus 16 over 3. So first we're going to subtract 16 over 3. And 0 minus 16 over 3 is negative 16 over 3. We bring down the negative 3x, and positive 16 over 3 minus 16 over 3 is 0. So those go away. Then we're going to divide both sides by negative 3. And negative 3 over negative 3 equals 1, so we're just going to have 1x, and we can just write that as x. We don't have to write the 1. Then negative 16 thirds divided by negative 3 is going to equal 16 ninths. Sorry, positive 16 ninths. So the point for our x-intercept is 16 ninths, comma, 0. Let's go ahead and plot that point. When you write 16 ninths as a decimal, it is 1.777777 forever, which is why I want you to write it as a fraction. But this 1.7 will help you know where to put it on the x-axis. So 1.7 is somewhere in here. Again, it does not have to be perfect. Okay, so to find our y-intercept, I'm going to show you the algebraic way, but notice that this is already in y equals mx plus b, so we already know that our y-intercept is going to be 16 thirds. Let's make sure we can find it on our own, though. Y equals negative 3 times 0 plus 16 thirds. So y equals 0 plus 16 thirds. And then that means that y equals 16 thirds, and our y-intercept is 0, 16 thirds. So even if you use y equals mx plus b and just write this down, you have to write down this part to have a complete answer, okay? So you can leave out all this if it's in y equals mx plus b, because it's obvious right there what your y-intercept is going to be. But you have to have this part written down, the point. Okay, so 16 thirds as a decimal is 5.333333 forever. So that will help us graph this on the y-axis. So 5.3 would be somewhere in here. Again, does not have to be perfect. And then it's really best if you have a straight edge of some sort, like if you have a ruler at home or something like that. Sorry about the noise. So that you can line up the points and actually draw a straight line, which I just attempted to do on an iPad screen. I'm kind of proud of that. Okay. So that is your graph of y equals negative 3x plus 16 thirds. And number 5 is the reason that you need to know how to do the y-intercept both ways, because this is no longer in y equals mx plus b form. And it's a lot more work to translate it into y equals mx plus b and then find your intercepts. So we're going to do it the way that we just taught ourselves. X-intercept is where you put 0 in for y. And then solve for x. So negative 5x, negative 4 times 0 is 0, so minus 0 equals negative 24. Negative 5x minus 0 is just negative 5x equals negative 24. And then we'll divide both sides by negative 5 to get x by itself. And x equals positive 24 fifths. And this one is a nice clean decimal. So you can write it as 4.8 if you would rather. So the x-intercept is 4.8, comma 0. All right, y-intercept time. For the y-intercept, we replace x with 0. So negative 5 times 0 minus 4y equals negative 24. So we have negative 5 times 0 is 0, minus 4y equals negative 24. And then 0 minus 4y is just negative 4y equals negative 24. Divide both sides by negative 4 to get rid of that. And we get y equals positive 6. And so the y-intercept is 0, 6. So now let's plot our points. So we have 4.8 on the x-axis. And then we have positive 6 on the y-axis. And then we are just going to connect the dots. And that is our graph for number 5. Okay, last example. The x-intercept. We're going to replace y with a 0. So this is going to equal 0, so that gives us 5 halves x plus 0 equals 6. 5 halves x plus 0 is just 5 halves x equals 6. And I'm going to show you a trick about fractions. So instead of trying to divide this by 5 halves, sometimes that can get confusing to type into a calculator, and it can kind of mess with you. But if you want to, you can multiply both sides by 2. And so that's going to give you, these 2's will cancel each other, and you'll get 5x over here. 6 times 2 is 12. Then you can divide by 5. And 5 over 5 cancels, and we get x equals 12/5. So in my opinion, it's easier to deal with fractions that way whenever you're instead of having to divide by 5 halves. But that's up to you. You can do it however you want. So our x-intercept is 12/5, 0. Our y-intercept now is when we put 0 in for x. So 5 halves 0 plus 5/6y equals 6. 0 plus 5/6y equals 6. That means that 5/6y equals 6. And I'm going to do this again, multiply both sides by 6 to get rid of that. And we get 5y equals 36. Then we can divide both sides by 5. And we get y equals 36 over 5. So we have 0, 36/5. And I kind of forgot about it this time, but we can also do these in decimal form. These both make nice clean decimals. So 12/5 is equal to 2.4. So we can have 2.4, 0. And then 36/5 is equal to 7.2. So this one can be 0, 7.2. All right, so 2.4 on the x-axis and 7.2 on the y-axis. And then we just connect the dots. All right, that is your graph for number 7. Thanks for listening and have a great day.